Over 1 billion butter and cheese products are made worldwide every year. From rich cheeses and classic dairy butter to plant-based options like peanut butter, forming the backbone of cuisines across the globe. But what if, for just one day, butter and cheese completely disappeared? Millions of baked goods would never leave the ovens, fast food chains would grind to a halt, and the entire food supply chain could face paralysis. To prevent such a scenario, a massive industry worth trillions of US dollars continues to operate relentlessly with near-perfect precision. Today, join Agriculture Insight as we explore the world's most advanced butter and cheese manufacturing plants, where enormous production lines control every gram of fat, every degree of heat, and every second of time to create the soul of millions of dishes each day. All of this will be revealed right now. Introduced in the 1950s, born from the need to create a cheese slice that was more stable and easier to store than traditional cheeses, Kraft Singles today are found almost everywhere. From burger counters and industrial kitchens to global fast food chains, with billions of slices produced and consumed each year. More visually appealing than cheddar when melted, more resilient than fresh mozzarella, yet not legally considered real cheese, this product is in fact a processed cheese, containing only about 51% real cheese. The rest is water, emulsifying salts, and technical ingredients designed to control structure and melting behavior. With overwhelming popularity in the processed cheese slice segment, Kraft Singles are estimated to generate around USD 1.5 billion in profit annually for Kraft Heinz, enough to place the product among the company's crown jewels, alongside global icons such as Heinz Ketchup, Kraft Mac and Cheese, and Velveeta. To create a perfectly melting Kraft Singles slice, everything begins with ingredient selection, where base cheese blocks such as cheddar, Colby, and other semi-hard cheeses are carefully chosen. Once the ingredients meet the required standards, the cheese blocks are transferred onto the processing conveyor and enter the grinding stage, where the breakdown of structure is controlled down to the finest detail. At this stage, the cheese blocks must be kept in a solid state to prevent phase separation of fat and protein prior to emulsification. Industrial blades rotate continuously to break the cheese blocks into smaller pieces, increasing surface area and preparing the material for the subsequent emulsification cooking step. At the same time, air becomes the invisible enemy of the entire process. If oxygen is drawn in during grinding, it can trigger oxidation reactions, altering flavor and disrupting the color that must remain stable. For this reason, the grinding system is designed to be nearly fully enclosed, minimizing air intrusion and keeping the cheese in an absolutely stable state before it moves on to the next stage. With traditional cheese, shelf life after opening typically lasts only 5 to 7 days. In contrast, Kraft Singles can remain stable for 30 to 60 days in the refrigerator. This difference does not come from magic, but from the step where emulsifying salts and water are added, and the mixture is cooked in a continuous system for just a few minutes. Here, the cheese transitions from a solid, separated, and difficult-to-control state into a molten form, ready to be shaped and transformed into millions of Kraft Singles slices. After melting, the cheese is poured into molds, where it solidifies again under controlled temperature and pressure, forming uniform blocks ready for the cutting stage. From these formed blocks, the processed cheese is sliced into standard pieces of approximately 9 × 9 centimeters, only a few millimeters thick, using high-speed cutting systems operating continuously. Immediately after cutting, each cheese slice is wrapped in a thin film to secure its shape, then sent directly through a controlled cooling water bath. The cold water rapidly lowers the temperature, locking in thickness and cut edges before the slice has a chance to spread or warp, while also bringing the temperature down to a safe range so the subsequent wrapping process can proceed smoothly. The entire cycle is completed in approximately 30 seconds. using a circulated water system that is sterilized and closely monitored, ensuring that each slice retains its structure without absorbing water. This practice of individually wrapping each slice during the cooling stage is a distinctive feature of Kraft's production line. Rather than allowing the cheese to fully stabilize before packaging, Kraft fixes the shape and state of each slice within the thermal process itself, ensuring high uniformity, easy separation, and consistent quality in use, an approach that is critical for large-scale industrial production. After the cooling stage, the slices are transferred directly to the automated packaging area, where pick-and-place robots handle the entire operation. Mechanical arms move along precisely repeated paths, lifting each slice, placing it into trays, and aligning positions before sealing at speeds that can exceed 200 slices per minute. Human workers only supervise and perform random inspections, while consistency, hygiene, and production pace are entrusted entirely to machines, fast, precise, and tireless. Farewell to Kraft Singles and the familiar rich, creamy cheese slices. Up next, we turn to butter, the strategic pillar of the global dairy industry. To produce butter, everything begins with fresh milk, a familiar raw material that is strictly controlled from the very first moment. When tanker trucks arrive at the plant, the milk is pumped directly into stainless steel silos within a closed system, with minimal exposure to air. Temperature is kept stable from farm to factory to prevent oxidation and bacterial growth. Before entering production, the milk must pass a series of tests: fat content, pH, microbiological levels, antibiotic residues, and impurities. A single deviation is enough for an entire truckload to be rejected, because in butter production, quality always takes precedence over yield. Milk that has met quality standards is gently warmed and fed into a centrifugal cream separator. At speeds exceeding 7,000 revolutions per minute, the lighter fat fraction is separated as cream, while the remainder becomes skim milk. The cream remains liquid, fat-rich, and serves as the core ingredient for subsequent churning and butter production. After being pasteurized at approximately 85 to 90 degrees Celsius for a short period and aged at 5 to 10 degrees Celsius for several hours, the cream remains in liquid form and is transferred directly into an industrial butter churn, where the transformation truly begins. Under continuous agitation, the fat structure breaks down. The cream gradually thickens, then small butter grains appear and aggregate together. The liquid separated during this process is buttermilk, commonly used in food processing, while the butter in granular form is collected and prepared for the subsequent processing stages. Immediately afterward, the butter mass is washed with cold water at 5 to 10 degrees Celsius to remove nearly all remaining buttermilk, a critical step that determines the product's shelf stability. If buttermilk is not thoroughly removed, the butter can turn sour within just a few days. When properly handled, however, the butter can maintain its quality for many months. Next, the washed butter is transferred to specialized working machines. Through controlled pressing, folding, and mixing, the butter gradually transitions from a loose, non-uniform granular state into a cohesive, smooth, and pliable mass, with moisture evenly distributed throughout. At this stage, the butter reaches a fat content of 80 to 82%, meeting global commercial standards. Finally, the butter is formed into small retail blocks or large units of 20 to 25 kilograms and even 200 to 500 kilograms for industrial kitchens. Batches of butter weighing more than an automobile. Just minutes later, the butter enters the most demanding area of the factory, the packaging zone, where temperatures are constantly maintained at 10 to 15 degrees Celsius, nearly as cold as a meat storage facility. Here, speed is no longer an advantage but a matter of survival. If the line runs 3 to 5 seconds slower than designed, friction and ambient heat alone are enough to soften the butter's surface and cause deformation before sealing can occur. Packaging, therefore, serves more than a protective outer layer. The factory uses multi-layer materials coated with polymer or thin aluminum to block light and foreign odors. Even a minor deviation can cause the butter to lose its aroma and decline in quality within just a few weeks. Before shipment, the butter undergoes final quality checks on packaging integrity, weight, shape, and sample analysis to ensure compliance with standards. If Chinese people cannot live without chili oil, Americans can hardly enjoy bread without peanut butter. Each year, the United States consumes approximately 152,000 metric tons of peanut butter, averaging about 2 kilograms per person, generating a multi-billion-dollar market annually. The first step in peanut butter production is washing the peanuts, where dirt and impurities are removed and underweight or damaged kernels are separated. Only peanuts meeting structural and weight standards proceed to the next stages. The first step in peanut butter production is washing the peanuts, where dirt and impurities are removed and underweight or damaged kernels are separated. Only peanuts meeting structural and weight standards proceed to the next stages. After roasting, the peanuts are immediately transferred to a critical refining stage, skin removal, a step that directly determines the color and flavor of the final peanut butter. Here, the kernels pass through a modern skin removal system, where compressed air at 6 to 8 bar, combined with ultrafine grooved rollers, strips away the thin skins without breaking the kernels. Even a small amount of residual skin can introduce slight bitterness and darken the color, noticeably affecting smoothness and richness. Next, the peanuts move along a vibrating conveyor with high-power suction fans to remove any remaining skin fragments. This process also cools the kernels naturally, preventing overcooking before grinding. Before milling, the peanuts pass through an optical sorting system. High-speed cameras scan 5,000 to 7,000 kernels per minute, detecting burnt, discolored kernels or foreign matter, and ejecting them instantly using compressed air. When peanuts enter the rotary grinding system, high-speed shear and friction release natural oils, forming a smooth, golden paste without dairy ingredients. Heat from grinding improves flow before stabilization. Salt, small amounts of sugar, or vegetable oil are then added in precise proportions to refine flavor. The mixture is heated to about 180 degrees Fahrenheit to stabilize structure, reduce bacteria, and extend shelf life, with low moisture and high oil content, minimizing the need for preservatives. At the final stage, the peanut butter is kept at a stable warm temperature and transferred directly into an automated packaging line, where controlled heat allows the product to flow smoothly without foaming, while maintaining filling accuracy with deviations of only a few grams per jar. The peanut butter is then dispensed into glass or plastic containers ranging from 250 grams to 1 kilogram and sealed immediately. As the temperature gradually drops, a slight vacuum forms inside the container, limiting oxygen intrusion and preserving flavor. Immediately afterward, the product undergoes rapid cooling, labeling, and final inspection before being packed into cartons. The entire process takes place in a fully sterile environment, strictly meeting food safety standards. When it comes to peanut butter on the global market, Skippy stands out as the most recognizable name. Founded in 1933, Skippy built its success on an approachable flavor, consistent texture, and wide international distribution. With annual revenue exceeding $1 billion, Skippy represents both massive economic value and a lasting cultural presence in everyday food habits. Alongside Skippy, the market also features major competitors such as Jif, Peter Pan, and Justin's, which together drive competition and innovation in the peanut butter industry. You might think of mayonnaise as just a simple condiment in your daily sandwich or salad. But in the global food industry, this creamy sauce is considered white gold, generating a staggering $14 billion in revenue each year. In the global condiment market, the US holds the crown thanks to its massive production scale and advanced technology. Led by Hellmann's, the giant brand that commands 45% of the North American market. Every day, around 1.2 million bottles of mayonnaise are produced and shipped from Hellmann's factories, finding their way onto millions of dining tables worldwide. If Hellmann's is the king of the mainstream, familiar, easygoing, and everywhere, then Duke's is the choice for the few. With a no-sugar formula, a thick and creamy texture, and a bold southern flavor, Duke's doesn't aim to please everyone. It wins over those who value authenticity and demand precise control over every ingredient. To produce millions of jars of high-quality mayonnaise each day, it all starts with one essential ingredient: eggs. And that journey begins on the laying hen farms. There's a little-known fact. Egg quality doesn't depend solely on breed or nutrition. It also stems from the hen's comfort, living conditions, and stress levels. In modern farms, animal welfare is no longer a choice, it's a technical standard. Laying hens are raised in clean, well-ventilated housing systems, with natural lighting and fresh air circulation controlled automatically around the clock. Their diets are carefully tailored to each growth stage, rich in protein and balanced in minerals, to strengthen immunity and ensure consistent laying cycles. There's no panic clucking, no overcrowding, no unpleasant odors. Instead, a closed-loop system is maintained, where every egg is produced under optimized conditions of nutrition, environment, and health. It's the foundation behind the consistent quality of millions of jars of mayonnaise. After a period of meticulous care, the hens enter their laying phase. In modern farms, whether free-range or industrial, the health and productivity of each hen is closely monitored to ensure optimal efficiency. Nesting areas are specially designed with clean, cushioned spaces, providing a calm environment for the hens to leave behind a fresh gift each day. On average, a hen lays one egg every 26 hours, nearly one egg per day. At an industrial scale, egg collection is handled by highly efficient automated systems. As soon as the egg drops onto a soft tray beneath the nest, it is gently transferred onto a conveyor belt that runs the length of the housing rows and carries it straight to the central collection area, without any human intervention. Thanks to this system, large farms can gather between 200,000 and 500,000 eggs per day, meeting the enormous raw material demand of the mayonnaise industry. If that number feels hard to grasp, consider this. Eating through all those eggs would take over 1,300 years, assuming you had the lifespan of a legendary tortoise. Once collected, the eggs are temporarily stored under tightly controlled temperature and humidity conditions before continuing on to the next stage, processing at the factory. Mayonnaise is primarily made from egg yolks and vegetable oil. Therefore, handling the eggs properly before they enter the production line is a critical step. As soon as the eggs arrive at the facility, they undergo a strict quality control process. Advanced LED candling systems and high-resolution image sensors are used to detect any defects such as hairline cracks, thin shells, fertilized eggs, or internal impurities. At the plant, more than 60,000 eggs can be inspected every hour, fully automated, with no manual handling required. Any egg that fails to meet the standards is immediately removed from the production line. Only those that pass strict criteria for shape, size, and safety are allowed to proceed. In certain markets like the United States, egg washing is a mandatory step to remove dirt, feathers, and surface bacteria. Eggs are sprayed with warm water, combined with a mild sanitizing solution to clean the shell without compromising the structural integrity of the egg inside. However, in Europe, this process is generally avoided to preserve the egg's natural protective layer, the cuticle, which helps prevent bacterial intrusion. Instead, strict hygiene standards are enforced throughout the production and storage process to maintain cleanliness without stripping away this natural barrier. After washing, the eggs are sorted using an automated weighing system. Each egg is weighed and categorized into standard size classes, such as S, M, L, or XL. This classification ensures consistency in egg size across production batches, helping maintain stable, predictable quality in the mayonnaise manufacturing process. Next, the eggs are transferred to a specialized separator to extract the yolks, the key ingredient in mayonnaise, as they contain lecithin, a natural emulsifier that allows oil and water to blend smoothly. The machine operates based on physical separation principles such as centrifugal force, gravity, or rolling mechanisms, starting with a gentle cracking of the shell to avoid breaking the yolk. Compared to manual labor, modern separation machines are 10 to 20 times more efficient, capable of processing thousands of eggs per hour. These systems not only save time but also ensure that the extracted yolks are pure, hygienic, and ideal for high-quality mayonnaise production. The yolk is then separated from the white and shell through dedicated chambers. The system operates at speeds of up to 60,000 eggs per hour, yet the yolk breakage rate remains below 2%. After separation, the liquid yolk is passed through a low-pressure microfiltration system to remove any remaining impurities or shell fragments. It then undergoes low-temperature pasteurization, around 60 to 65 degrees Celsius, a process gentle enough to eliminate harmful bacteria without denaturing lecithin. After processing and preparation, the products are packed into specialized containers, stored under strict conditions, and transported to mayonnaise manufacturing facilities to be used as a key ingredient in the next stage of production. In addition to using liquid yolk, many factories also convert yolk into dried egg powder through spray drying or freeze drying methods. When rehydrated with water, this powder restores the emulsifying properties of fresh yolk, preserving the flavor and thickness of the mayonnaise. And now, let's dive into the mayonnaise production process, the part we've all been waiting for. This is where science, precision, and flavor come together to create one of the world's most iconic sauces. First, the pasteurized liquid egg yolk is automatically pumped from intermediate storage tanks into large stainless steel mixing vessels, each with a capacity ranging from several hundred to several thousand liters. This closed-loop pumping system prevents external contamination and preserves the yolk's integrity, ensuring maximum purity and optimal emulsifying properties. In some factories, fresh yolk is replaced with dried egg powder, a remarkable ingredient that can be revived with just pure water. Before use, the powder is finely sifted under high pressure to remove clumps and impurities, then dissolved at precise ratios in a specialized mixing tank. After the egg yolk is pumped into the mixing tank, other ingredients such as vinegar or lemon juice, salt, sugar, and various additives like mustard, stabilizers, and flavor enhancers are added in a programmed sequence. Have you ever wondered why a bit of mustard appears in mayonnaise recipes? It's not there to add the spicy kick you'd expect in a hot dog. Instead, it rounds out the flavor, adds depth, and more importantly, it helps emulsify. The amount is so small you might not notice it's there, but take it away, and you'll feel like something's missing, even if you can't quite explain what. Finally comes the refined vegetable oil, most commonly soybean oil, which accounts for 65 to 80% of the total mixture and plays a key role in giving mayonnaise its rich texture and creamy body. Soybean oil is chosen for its neutral flavor, excellent emulsifying ability, and high stability. Before being used in production, the oil undergoes a thorough refining process, including deodorization, decolorization, and impurity removal to ensure absolute purity. This level of refinement helps create mayonnaise with a smooth, creamy texture, an appealing ivory white color, and an extended shelf life. Once all the ingredients have been added in the correct order and roughly blended, the mixture enters the emulsification stage, the most critical step in the entire production line. Here, high-speed mixing equipment, operating at up to 3,000 revolutions per minute, works continuously to disperse oil droplets evenly into the water phase. Egg yolk, naturally rich in lecithin, acts as a powerful emulsifier, stabilizing the structure of the mixture and preventing separation over time. In most modern systems, emulsification and homogenization happen at the same time, all inside one machine. As the high-speed mixer runs, it breaks down the oil into tiny droplets. That's homogenization. While the lecithin in the egg yolk wraps around those droplets and helps bind them with water. That's the emulsifying part. This combo gives the mayo its smooth, creamy texture and keeps it from separating over time. Once the process is done, the mixture gets pretty warm from all that mixing, so it's quickly cooled down to lock in the structure and preserve the fresh taste. Before entering the packaging stage, technicians collect samples of the mayonnaise for testing. The product must pass strict evaluations for viscosity, pH, color, taste, and emulsion stability to ensure consistent quality and food safety. At the same time, microbiological tests are also carried out to detect and eliminate any risk of contamination. After passing rigorous quality checks, the finished mayonnaise is pumped into various types of packaging, including plastic bottles, single-serve sachets, and glass jars, all carried out on a fully automated, closed-loop packaging line. For jars and bottles, automated filling systems dispense the mayonnaise with milliliter-level precision. In advanced facilities, the line can fill up to 15,000 bottles per hour, meeting the demands of high-volume global production. Once filled, each unit moves to the capping station, where lids are sealed tightly with even mechanical force to ensure an airtight seal. Labels are then automatically applied, displaying full traceability and expiration details. From filling to final packaging, every step takes place in a strictly controlled environment to ensure hygiene and precision, minimizing contamination risks and preserving product integrity until it reaches the consumer. For single-use sachets, the mayonnaise is dispensed and heat-sealed in a matter of milliseconds using high-speed sealing technology. The entire process from filling to sealing takes less than 1 second per unit. And from the very first egg to the final squeeze of sauce, every jar of mayonnaise is the result of cutting-edge technology, engineering precision, and meticulous care at every stage of production. However, that guilty feeling after the first spoonful is hard to avoid. Behind its smooth, rich, and creamy texture lies an energy bomb, with nearly 100 calories per tablespoon, making mayonnaise one of those deceptively indulgent foods that can quickly lead to weight gain if you're not careful. Compared to most other fast food items, the hamburger is one of the world's most powerful profit-generating machines, thanks to its low production costs, extreme standardization, and ultra-high service speed. As a result, this seemingly simple sandwich can be replicated tens of billions of times each year, giving rise to a global business empire valued at over USD 300 billion. The journey of making a burger begins inside massive industrial mixers, where flour, yeast, water, sugar, salt, butter, and eggs are adjusted according to McDonald's proprietary formula, a system of ratios that exists only within internal production specification sheets. Inside the factory, the dough is never kneaded by hand. It is pressed, stretched, and twisted by machines capable of handling 1-2 tons per batch, spinning at over 100 revolutions per minute. After mixing, the dough is transferred to a controlled proofing stage, where the temperature is maintained at around 30 degrees Celsius and humidity is kept stable to allow the yeast to perform at its optimum. Next, the dough is automatically divided into precise portions, typically ranging from 60 to 70 grams, a figure carefully calculated so that, once baked, each bun reaches a diameter of about 10 centimeters, fitting perfectly with a standard hamburger patty. Before entering the oven, the surface of the buns is misted with steam and coated with a thin layer of egg wash, creating the signature golden color. In less than 12 minutes of baking at temperatures above 200 degrees Celsius, thousands of identical buns are completed, uniform, precise, and ready for the next stage of the production line. Once cooled, the buns are cleanly split in half by an automated slicing machine, ready for the packaging stage. The bun halves are then placed onto conveyor belts, neatly aligned and sealed using airtight packaging systems, helping preserve freshness and optimal flavor. In a hamburger, cheese is not just added for richness, it is engineered to melt at precisely the right moment. Most major burger chains use processed cheese, often based on cheddar or American cheese, enhanced with emulsifying salts to control its structure when exposed to heat. As a result, the cheese begins to soften at around 60 degrees Celsius and fully melts at approximately 75 to 80 degrees Celsius, evenly coating the patty without separating into oil or clumping. A change of just a few percentage points in moisture or fat content can cause the cheese to melt too quickly or unevenly, disrupting the familiar smooth, creamy sensation of a perfectly made hamburger. Once the buns are completed, the production line immediately shifts to preparing the meat patties. On a parallel processing line, the patties are handled within a closed system, beginning with the selection and cutting of beef into standardized sizes, before being fed into high-capacity grinders to create a smooth, uniform mixture. What few people realize is that each patty does not come from a single cow. Rather, it is the result of a carefully controlled blend from around 200 cattle per day, designed to lock in flavor and ensure that every burger leaving the factory delivers the same familiar taste. Once the meat mixture reaches a smooth, cohesive texture, it is fed into patty-forming machines, systems programmed with near-absolute precision. Here, the meat is pressed into perfectly round patties, with thickness and structure tightly controlled. Pre-calculated pneumatic pressure ensures each patty is firm to the touch without cracking or breaking. Immediately after shaping, the patties are sent through a rapid chilling stage where powerful streams of cold air reduce the temperature to around 0 degrees Celsius in just 3 to 7 minutes. This process locks in the meat's structure, preserving moisture and ensuring an ideal tender texture when the patty is later cooked. When all the ingredients are ready, a McDonald's burger begins to be assembled through a process that has been standardized to near perfection. The bun is placed onto a hot grill for just a few seconds, enough for the surface to lightly toast and release its signature buttery aroma, while the inside remains soft and familiar. A layer of McDonald's signature sauce is applied with precision using a calibrated dispenser, just enough to bind the components without soaking the bread. Next, the layers are stacked in a pre-programmed order. Finely shredded lettuce for a fresh crunch, evenly sliced pickles for that familiar tang, a perfectly cooked beef patty, and on top, a slice of cheddar cheese that melts at exactly the right moment. Not too early, not too late. The entire process takes only 30 to 40 seconds, yet the result is a burger with a consistent flavor profile, whether you take a bite in New York, Tokyo, or Paris. That is how McDonald's turns a simple burger into a global product. We leave behind the McDonald's factory, where hamburgers are replicated every second. Next, we turn to another empire, the world's most globally widespread fried chicken chain, operating a machine worth tens of billions of dollars each year, KFC. The journey of KFC chicken begins at dawn, when refrigerated trucks carrying fresh poultry leave the farms and head straight to the processing plant, where every step is timed down to the second. Upon arrival, the chickens are pre-cleaned and immediately fed into an automated production line with almost no downtime. Within minutes, they reach the leg separation area, where industrial cutting blades, calibrated to match the natural structure of the joints, operate continuously at a capacity of around 10,000 units per hour, ensuring uniform sizing. The carcasses are then transferred to the evisceration stage, where vacuum-based systems remove the internal organs in just 3 seconds. The pressure is precisely controlled, strong enough to clean thoroughly, yet gentle enough to preserve the integrity of the meat, marking a critical step in maintaining hygiene, quality, and consistency before the chicken moves on to the next stages of processing. Immediately after the initial cleaning and sorting stage, the chickens are transferred to a dedicated wing cutting line. Here, each bird is placed into a mechanical positioning mold that holds it in the correct orientation before automated blades make precise cuts at the wing joints. This entire section is designed to operate continuously in production shifts lasting up to 18 hours per day, ensuring a stable supply for thousands of restaurants across the same region. Once separated, the wings are moved onto a separate conveyor for inspection and classification. The remaining carcass then enters the central processing line. Throughout this sequence, from halving the body to separating the breast and sorting the thighs, the ambient temperature is maintained below 10 degrees Celsius to slow microbial activity and preserve the meat's structure. The body is split along a fixed axis, the breast is removed using controlled pulling force, and the thighs are routed to a separate line, all to ensure that each piece of chicken behaves almost identically when it later enters KFC's pressure fryers. From this point on, the chicken enters the most critical stage, where KFC's legendary recipe is finally activated. On an automated conveyor, the chicken moves continuously through the dry coating station, a secret blend of 11 herbs and spices, including salt, black pepper, paprika, garlic powder, onion powder, mustard powder, celery powder, dried ginger, oregano, thyme, and white pepper. The key does not lie in the ingredient list alone, but in the blending ratios and the order in which the chicken comes into contact with them. As the first dry coating is applied, the spices adhere directly to the surface of the meat. The wet coating that follows dissolves part of the essential oils, awakening the aroma. Finally, a finishing layer of dry coating locks the entire structure in place, laying the foundation for the crispy, aromatic, and richly flavored crust that defines KFC's pressure-fried chicken. Once the chicken pieces have been pre-processed and coated at the factory, they are transported under refrigeration to individual KFC restaurants and enter the final cooking stage. In the kitchen, the chicken is kept at low temperatures until frying time, then placed directly into pressure fryers, the key equipment that defines KFC's cooking method. The frying oil is heated and maintained at around 170 to 175 degrees Celsius. Thanks to this high-pressure environment, the chicken cooks faster without drying out. The outer coating becomes distinctly crispy, while the meat inside remains tender and juicy. Frying times are strictly controlled for each product type, after which the chicken is removed, drained of excess oil, and transferred to warming trays. The entire in-store process is designed so that every batch of chicken served has the same color, texture, and flavor, regardless of who prepares it or what time of day it is cooked. Alongside its traditional bone-in fried chicken, KFC has developed small chicken pieces by cutting boneless chicken into bite-sized portions, rather than grinding or molding the meat like industrial nuggets. Each piece remains whole muscle chicken, simply divided into smaller cuts to suit faster eating habits and shareable meals. Thanks to their smaller size, these pieces cook faster and more evenly in pressure fryers. With temperature and pressure tightly controlled, frying time is reduced by around 20 to 30% compared to larger cuts, while the meat inside stays tender, juicy, and well hydrated. At the same time, the coating fully covers the surface, creating a deeply crispy, evenly golden crust that delivers KFC's signature flavor. Cheaper than Pizza Hut, faster than Papa John's, and generating revenue far beyond the rest of the pizza world. That is, Domino's, a pizza machine powered by speed, technology, and scale, with annual revenue of USD 40 billion. The journey of producing nearly 3 million pizzas each day at Domino's Pizza begins with massive ingredient tanks inside highly automated production centers. Like everything in the fast food industry, pizza dough has its own formula. Flour, water, oil, salt, and sugar are measured precisely down to the gram, combined with Domino's Pizza's proprietary recipe that only a very small group of senior executives can access. The mixture is then fed into large industrial mixers, where powerful paddles continuously press and stretch the dough in a fixed cycle. This mixing force develops a smooth, elastic, and uniform dough, while temperature is tightly controlled to ensure that every batch delivers exactly the same result. After mixing, the dough is portioned and rounded entirely automatically. Each dough piece is cut to a pre-programmed weight, approximately 150 grams for small pizzas, 250 grams for medium, and 380 to 400 grams for large. The dough then passes through rollers and shaping surfaces that stretch the outer skin, forming smooth, round, airtight dough balls. The entire process takes less than 10 seconds per dough ball, moving too fast for human intervention. This stretched surface structure helps the dough maintain its shape, rise evenly, and resist tearing when stretched into a pizza base. On each production line, the system can operate continuously for hours, producing enough dough to supply hundreds of stores within the same region. The dough balls for small, medium, and large pizzas are then placed precisely into molded trays, ready for cold fermentation and distribution. Next, the dough enters a massive spiral cooling system, where the temperature is reduced to 3 to 4 degrees Celsius to slow down fermentation without compromising the quality of the dough. Domino's does not operate frozen pizza factories. Every pizza is made fresh at each individual store and sent straight to the customer. In Domino's kitchens, the dough is taken out to naturally return to temperature before being placed on a cornmeal-dusted work surface. The motions of rotating, pressing, and supporting the dough with the back of the hand are not just about shaping, it's about pushing air from the center toward the edge, forming an even rim that determines how the crust rises in the oven. Each pizza maker senses the dough differently. Hand pressure, rhythm, and stopping point are never exactly the same. A skilled worker needs only 20 to 30 seconds, yet can still create a rim that is even, intact, and stable. These subtle variations in technique leave a distinct personal signature on each crust, enough that two pizzas made from the same batch of dough can feel slightly different from the very first bite. Next, the tomato sauce is spread in precise circular motions. Cheese is evenly distributed across the surface, avoiding the center to prevent the crust from becoming soggy or baking unevenly. Toppings are weighed to exact portions, ensuring that every pizza, whether in New York or Tokyo, delivers the same consistent experience. Finally, the pizza slides into a high-temperature conveyor oven and emerges after 6 to 7 minutes, with a golden crust, fully melted cheese, and gently bubbling toppings. During events like the Super Bowl, when millions of pizzas must be sold within just a few short hours, speed becomes a matter of survival. Pizza makers are not just selling food, they are racing against the clock, where being delayed by just a few seconds can mean hundreds of orders falling behind on the biggest sports night in America. Every year, millions of gingerbread house kits are produced on industrial assembly lines, becoming iconic holiday treats with their golden crispy cookie walls, colorful candies, and the warm ginger aroma of Christmas. The process begins in giant mixing tanks where flour, brown sugar, molasses, butter, and ground ginger are precisely measured and blended before moving to the kneading machine, forming a uniform dough block weighing nearly 200 kilograms per batch. This dough then passes through a high-pressure steel roller system, pressed thin to just 6 to 8 millimeters to ensure a perfectly flat surface for cutting. While the dough is still soft, patterned rollers stamp doors, roofs, and decorative details directly onto the sheet. Once baked to a crisp texture, the panels become as sturdy as miniature bricks, ready for assembly. The wall and roof pieces are bonded together with royal icing, a mixture of egg whites and powdered sugar that bakers often call the Christmas epoxy glue for its incredible sticking power. Finally, candies, sprinkles, and icing details are added to complete a lively gingerbread house that looks just like a tiny winter scene. And as soon as the gingerbread house production comes to an end, the assembly line immediately shifts its rhythm to another Christmas icon, the candy cane. The journey of crafting this legendary treat begins with a step that seems simple, but actually determines the entire quality: mixing and cooking the sugar. Sugar, glucose, and syrup are poured into large kettles, heated, and continuously stirred until the mixture becomes thick, uniform, and crystal clear like hot honey. Once it reaches the ideal consistency, the syrup is poured onto cooling tables or steel conveyor belts, where technicians or machinery stretch and fold it repeatedly to develop the perfect elasticity and airy texture. At this stage, the candy mass is divided into two portions, one left in its natural white color, and the other mixed with just 0.3–0.5% coloring to achieve its signature red hue. The two masses are placed side by side and fed into a high-temperature rolling and pulling system. Under continuous pressure, the red and white layers are compressed together without blending, forming perfectly straight stripes. As the combined candy block moves through the twisting machine, the rotating shaft gently spirals the strip into a long cylinder, gradually thinning it down to the width of a pencil. This is when the iconic red and white swirl becomes the most vivid. Finally, the candy rope enters a high-speed cutter, sliced into segments about 12 to 15 centimeters long. While still soft, each piece is bent by the conveyor system to form the distinctive hook shape of a candy cane before being fully cooled to lock the form in place. Say goodbye to the soft, twisted candy ropes. We're stepping into the crispy world of Lay's, where every potato is carefully selected and processed before becoming part of the more than 200 million chips produced each day. Every potato used for Lay's goes through a streamlined yet almost perfectly precise process. After being washed and sorted, the potatoes enter a specialized peeling machine. Inside the rotating drum, the surface of each potato rubs continuously against the chamber walls, causing the skin to come off within seconds, while strong water jets wash away any remaining impurities, leaving behind smooth, flawless potatoes ready for slicing. Immediately afterward, the potatoes are transferred to a high-speed slicer. A set of spinning disc blades applies gentle pressure to each potato, producing slices just 1.5 millimeters thick. A measurement Lay's has standardized after years of optimization to ensure every chip fries quickly, cooks evenly, and achieves its signature crispness. From the high-speed blades, the process shifts into a stage of precise heat control. The potato slices enter a vat of refined oil, kept at a stable 175 degrees Celsius, and are fried for about 3 minutes to develop a uniform golden crunch. The oil is continuously filtered, allowing the system to operate 24/7 and process tons of potatoes per day while maintaining consistency. Thanks to this closed-loop system, Lay's preserves its iconic thin, light, crispy quality on a global scale. If Lay's is a race against time, Hershey is an art of structural control. Every year, the Hershey Company produces more than 500,000 tons of chocolate, fueling a worldwide wave of sweetness. The journey of a Hershey's Kiss begins immediately after the tempering stage, when the chocolate reaches its perfect smoothness and glossy finish. The liquid mixture is fed into a molding machine, dropping onto the conveyor in the signature little kiss motion, the very origin of the name Kisses. From there, the chocolates enter an almost endless cooling tunnel, where the stable temperature allows each piece to solidify evenly. Those that meet the quality standard are wrapped in foil, fitted with the iconic paper plume, and sent along a spiral conveyor toward the automatic weighing section. Alongside the Kisses line, the Hershey bar production system runs continuously with preheated molds ready to receive streams of liquid chocolate with absolute precision. The molds then move into a tightly controlled cooling chamber that ensures each bar sets quickly while remaining silky smooth. Once fully cooled, the machine flexes the molds gently to release the bars, then flips them over to drop the finished pieces onto the packaging conveyor.